Okay, so we're looking at lesson 2.2, modeling and solving quadratic applications. So basically we're taking quadratic equations and we're going to apply them to actual situations, okay? So remember that when we do quadratics, we've been making like a lot of parabolas, right? Well, notice like in this case, this is about like a little boat that's a fire boat, which is putting out a fire in a building, right? And notice the stream of water is going up and coming down and making this parabola shape. Or if like somebody was shooting a basketball, right, into a hoop, let's say that's my hoop, and it goes up and it kind of comes down. It's kind of a sorry, you guys can't see that. It goes up and that's my basketball. Don't judge me. Okay, it goes up and goes in. That's kind of a parabola shape. So there's a lot of things that like you can kind of predict using parabola. And actually, when you guys take physics, you're using the quadratics a lot. Okay, when you're talking about something that goes up and comes down. Okay, so anyways, so we got this fireboat and it's helping put out a fire, and the distance from the barrel end of the water cannon. So the barrel end is just like the end of the water cannon. The distance from that end to the roof of the warehouse to here is 120 feet. So in this case, I'm going to use 80 feet instead of 120 because remember, I'm creating a different question that you can kind of solve on your own. And we're going to say in our case that the water shoots up not 50, we're going to say 40. So when you do this question on your own, make sure you use these numbers. I'm just using some new ones. Okay, so sketch a graph and write an equation of the parabola that models the path of the water from the fireboat. All right, so first I want to look at the scale. And if I try to go by ones here, because remember the distance we're talking about from here to here, in our case, we're saying this distance is 80 feet. But remember, yours is 120. And then in our case, we're saying right now that it's going up 40, right? So notice how the distance across, that's your x-axis, right? So here, we're going 80 feet. So let's go by tens, all right? So on this x-axis, we're going to go by 1, 2, 3, 4, 50. And then that means this will be 100. This will be 150 and so on. Okay, then we're going to go up by tens as well. So those little marks there are 50 and 100. Okay, so let's go ahead and sketch this out. So remember, we're starting over to the right at 80, right? So that means the boat's about right here. And then it's shooting its water cannon up. It's coming all the way over and ending up on this warehouse about right over here. Okay, so that's the bait. That's right the tip of the cannon right there. Water shooting up. Okay, going across. Okay, so now what we want to do is now that we have our x-intercepts, because again, look at the graph. Where we started and where we ended, that's the x-intercepts of your graph, right? So we can use that to figure out the rest of the equation. So what we're going to do is figure out the middle of 80 and 0. Well, that would be 40 right here in the middle. So there's our line of symmetry. So that'll help us figure out the rest of this. So that means that up here, right here, remember that we said that the height of the water was 40. So all I got to do up from that point is go up 40, and then there's our vertex. Because remember, it's going up here, and you guys are going up 50. Okay, so there's my vertex. There's my x-intercept, so I can make a quick little sketch. Try to make a little U. All right, so now I can use this information to figure out the equation. Well, first of all, the vertex point, that's at 40, x value of 40, and the y value of 40. All right, so now let's set it up in graphing form. So y equals a times x minus h squared plus k. So let's fill in what we know. Okay, we don't know the a value. We do know the h value. It's positive 40, so when I plug it into the equation, I'm going to write minus 40. Okay, remember, we always switch that sign when you're both looking for the vertex and when you're plugging it in. All right, so now I'll put the plus 40 because that's our k value. And now what we want to do is figure out what is that a value. Well, to do that, if we know a value for x and a value for y, we can solve for a. And we do by just looking at the graph. We've got this point here. We don't want to plug in the vertex because that's going to kind of mess things up. But we could plug in an x-intercept, either 80, 0 or 0, 0. And I'm going to go for 0, 0 because 0, 0 just sounds easy. All right, so I'm going to take this point, 0, 0, and plug that into the equation. So 0 for the y, 0 for x, and now we're going to solve for just a. Okay, so one thing at a time. Okay, so now 0 minus 40, that's negative 40. And plus 40. And so now negative 40 squared, well, use a calculator or just do 4 times 4 and then add 2 zeros at the end because it's 40 times 40. So that's going to be 1600. So 1600 times a plus 40. And some of you are like, oh my gosh, that's such a big number. You can do it. It's not that bad. All right, so now minus 40. I'm going to solve for a. And we get minus 40 equals 1600. And the last step here would be to divide by 1600 to get a by itself. Okay, but we want to reduce that. So what I'm going to use is Desmos because I love the fact that you can just type in a fraction and it will reduce it for you. You can do it in your head if you want, but this makes quick work of it. So all I do is click this fraction button and boom, there's my reduced fraction. So it's negative 1 over 40. So you can kind of work that out in your head if you wanted to, but if you got the tools, use it. Okay, so there's my a value. So now I can set up my equation. We already knew that first part, right? This, so all we got to do is plug that into the a. So my equation is negative 1 over 40 with a value, and then I got x minus 40 squared plus 40. Okay, so there's my equation. So I got my graph, got my equation, so I can predict, make some predictions about that stream of water. All right, let's move on to the next one. Okay, so now looking at, oh yeah, one thing I forgot to mention too is that just so you know, like this equation kind of makes sense that we got a negative value here because if you think about it, this is a parabola that's flipped upside down. It's pointing down, so we should end up with a negative there. Okay, so now the next one with Mara. She's deciding to use a hose to water her outdoor plants. So here's Mara. She's watering her plants, and she notices the water coming out of her hose follows a parabolic path, or in other words, it's shaped like a parabola. When Mara uses her green garden hose, the greatest height of the water reaches 8 feet. Okay, so in our case, I'm going to use 10 feet instead. I'm going to say that this height right here is 10 feet, going up and down, and it lands on the plants 10 feet from where she's standing. So instead of using 10 feet here, I'm going to use 12. So I'm going to change this to 10 and this to 12. Remember, you have to answer yours, but I'm just using these instead, okay? So instead of 10, I'm going to use 12. And both the nozzle of the hose and the top of the flowers are 4 feet above the ground. Okay, so 4 feet above the ground. Okay, so that's, in our case, I think I'll use, let's say, I don't know, 6 feet above the ground. We'll say 6 feet up. Okay, so that's important to note that it's above the ground, okay? Because down here, this is kind of considered like our y-axis. So what I'll do, let's make a quick sketch of what this will actually look like. So we're starting here at 0, and we're going all the way to 12, right? Okay, but we're not actually starting on the ground. We're actually starting above the ground. To be exact, 6 feet above the ground or 4 feet above the ground here. So I'm going to go up 6 feet. Let's say that's 6. And this is where I'm actually starting at because I'm above the ground. So this is like the bottom of our graph. So then I go over to 12 feet because that's where it hits the flowers. Okay, and then my height, the height reaches 10 feet above the ground. So here's the ground, and then it reaches 10 feet up. So that means I want to go up here to 10. And then there's kind of like my vertex point somewhere here in the middle, right? And then if it's right in the middle of 0 and 12, that means this is 6. So that vertex point is at 610. Okay, so it kind of like comes out of our hose here, and then comes up, and then hits the top of the flowers there, okay? Okay, so that should help us figure out the rest of this. So there's our vertex at 610. All right, we can use that to solve for the equation, which is the next question. Okay, so let's set up just like we did in the last problem, where we're going to plug in what we know using graphing form. Okay, so we have A times x minus 6 squared plus 10. Okay, so what I'm going to do is I'm going to plug in, I could choose to plug in this point here or this point here. So this one's at, let's see, 12.6, and this one's at 0.6. So I'm going to plug in the y-intercept, which is that point there. Okay, so I'm going to plug in 0 for the x and then 6 for the y. And make sure you plug in the right values. Okay, so make sure you're paying attention. If that first one is x, that should go there. Here for x, so 0 there. Okay, and then minus 6 plus 10. Okay, so now 0 minus 6 is negative 6. But if I square negative 6, that's 36. So it's actually right 36a, like this. Okay, so now we want to subtract 10 from both sides. And we get negative, let's see, we get negative 4 equals 36. Divide both sides by 36. And we could use our Desmos calculator, or I noticed that both of these can be divided by 4. So then I get a equals negative 1 over 9. Okay, so there's my a value. So let's write out the equation. Negative 1 over 9 times x minus 6 plus 10. Now remember, again, going back to here, remember we wrote negative 6 because if that's positive, this is negative. We always switch it. Okay, so just remember that. Okay, so now it says Mara has already determined that when she has the water on full blast with the red hose, so this is a different hose. This one's the green hose that she used, and down here we're talking about the red hose. It follows the path of this equation. Okay, so in this equation, we're going to use negative x minus 2 squared plus 11. So I'm just making up a new equation, right, to compare the two. So which hose will throw the water higher? Well, all we know by looking at this equation is the vertex, which is at 2 and 11. And we're talking about how high the water goes, right? So which of these values tells us that? Well, that would be the y value, because that tells us how high. So here it's at 11 feet, whereas here it's at 10 feet. So that means that the red hose, in my case, is higher. Now, make sure you're looking at your equation for these numbers that are on the homework and comparing it to this equation. But in my case, it's higher. Okay, so now what's the domain and range? For the green hose, well, I have to go back to this equation here, over this graph. Okay, so it starts over here at the left on the y-axis. So the x value to the left is 0. And then the limit to the right stops over here at this dot. And so that x value is 12. And we want to include those because that's kind of like the starting point and the ending point. So those are included, so we'll use a bracket. And now the range, well, that's the lowest y value, which is 6. And then the highest y value, the highest point of the graph, is at 10. And those are also included, so we put a bracket. Okay? Oops, sorry, you guys can't see it because the webcam's in the way, but it's 6, 10. Okay, so go ahead and try that with your problems. With your problem. Okay, so now in this problem, we've got, it says the Spark City event planners are planning a big firework display. So fireworks that shoot up in the air and come down, sorry. Okay, for the 4th of July. The fireworks will launch from a boat in the bay and must land in a designated fire zone 100 meters away. So instead of 100, I'm going to use 80. Okay. 80 meters. Remember, yours is still 100. I'm just changing the numbers. To be visible above the buildings and the trees, the fireworks must reach at least 30 meters high. Okay, so let's first, there's a boat, right? And then these fireworks are kind of going up and coming down, and it has to land over in this little safe zone area. So we'll consider this as like the safe zone. Now we know that from here to here, my distance is going to be 80 meters, right? Yours is 100. And then I'm going to say, for our case, that it has to be at least 40 meters high for people to see it. Okay, so that's what we want the fireworks to get up there. That way people can actually see them as they go up and down. Okay, so now let's use that to figure out the equation. All right, so now, again, let's kind of use the same idea that here's our x-axis and here's our y-axis, right? So that highest point on the y-axis that vertex is at 40. So that vertex, the y value is 40. But then we got to figure out the x value, right? So the x value, let's see, right in the middle of 80, because from here to here is 80, would be 40. So it's 40. Okay, so it's very similar to that first problem that we had before. Okay, so now here, matter of fact, it's going to be the exact same problem. So now, once I have that set up, I set up my equation. Okay, hang on. Just a second, Elijah. Sorry, guys. Set up my equation, plus 40. And now you do the same thing. So now I pick one of these points. I could use 0, 80 over here or 0, 0 and plug it in. And if you notice, this is literally like just like the last two problems. It's like the same steps. Oops, sorry, 0 goes there. Okay, so go ahead and plug in your values, figure out, and then you're going to have to figure out your A value by working through the same steps like we did up here. Okay? Okay, so now in this particular problem on the back side of your homework, I'm going to, again, set up some new equations here. So P of S equals negative S squared plus 6S. Okay, so we're going to use that instead of this one here. So we're talking about this company. It's called Math Starts, a company that sells math game apps. It can be modeled by... Are you going to shoot? Yeah. Okay, so sorry about that. So the sales can be modeled by this equation. So how much money they're actually making is modeled by this equation, okay? Where S is the sales price of the app in dollars. Okay, that's the sales price, how much they're actually selling it for. So this is how much they're charging people. And then this is how much they're making each day. Okay, that's their profit. Okay, so their competitor, Comet Math, has a different model for sales price and profits given by this table. So this equation is for Math Starts, and then the table represents the other company. So we don't have an equation for the Comet company. We just have a table, and then we have the equation represents Math Starts. So I created like a different table here for Comet, and this is a different equation for Math Starts. So the thing we want to look for in a table is when we want to know, well, the question is, what is the maximum profit for these models predicting, what is the maximum profit the models predict for each company? Which company can sell their apps for less to make the maximum profit? Let's first answer this question. What is the maximum profit the models predict for each company? Okay, well, as we increase the price, this is how much money they're making, right? So we get to this $8 and we get to 25, and all of a sudden that starts to go down again. When we charge $10, it starts to go back down to 23, 13 goes to 12.50. Well, what I want you to notice on this graph, let's see in this table, that on the left, this is the highest amount they can make, the maximum profit. Okay, so literally that would be the max, right? So in our case down here, the max as it goes up, it goes to $8, right? And it goes down off to the right. So here's the max amount, right? That's the max amount for the Comet company. All right. And then to the left, it's at $6. And here, when we charge 4, it's $6. And right to the right of it at $8, we charge $6. So if that's the middle, that's also like the vertex. Okay. So if I'm going up in price, right, and then start to come down in price, that point right here is this value. Okay. So, because the question is, what about Math Starts? What's the maximum profit for them? The max profit here for Comet is $8 or profit, but what about the other company? So what we're going to do is we're going to graph it. So we'll go to Desmos. And as you see, I've already got it graphed here. Now, by the way, if you guys use letters other than X, you might get something like this. You're going to need to put like a Y equals in front of it, or F of X, or F of S, or whatever your letter is. Okay, so there's our graph, right? And so we started, if we charge $0, we're not going to make any money. And then as this goes up, I'm going to hold this along here. You can see as the price that you charge increases, which is the X value on the left, the amount we make every day changes, right? So we get all the way up to here. And when we charge $3, we're going to make a max profit of $9. Because as soon as we go past $3 right here, like let's say we charge $4, right? Then we're going to make $8. So obviously that makes sense, right? The more you charge, the less people are going to want to buy something. And if people feel like it's reasonably priced, then they'll pay for it. And so that kind of like point where we kind of get to where people start buying it less is at $3. Okay, so our max profit though is $9 in this case. So for this case, it would be $9. So really, again, that was the vertex of that company, right? So it was at 3.9. So that's our max profit was $9 for this company, $8 for this company. Okay, so which company can sell their apps for less to make the maximum profit? Okay, well, at their max profit was $9, and they're selling at $3 per app, whereas this company is making $8 and selling at $6 per app. Okay, so that's not really a lot, right? So obviously this is the better deal. They're making more money. Or again, the question was which company can sell their apps for less? They're selling it for less to make their max profit. Well, that would be MassDarts in this case. So go ahead and plug this one into Desmos and then compare it to your common math problem here. Okay, so guys, on this one, this is a very similar to the ones I showed you in the first page. So we're talking about this grasshopper, right? So here's my little grasshopper. It's got his little legs. Here's his little body. I know this is a terrible grasshopper, but that's okay. All right, he's got his little head, his little antennas, right? So he's jumping like that. Okay, he's trying to jump as high and as far as she can. Okay, Gloria. Her best jump so far is 28 centimeters long and 20 centimeters high. So what I'm going to do is I'm going to help you set this up, but you're going to need to finish it. So from here to here, that's how long the jump is. It was 28. And how high, that was 20. Right? So now you're going to sketch a graph on here and write an equation in the parabola that best describes the path. Okay, so a couple recommendations before you start the problem. On the scale, I would recommend that you go by twos. Okay, so go by twos down here. So 2, 4, 6, 8. And that way you can fit this full 28 centimeters on the bottom. So you can kind of count it out as you go. 2, 4, 6, 8, 10. And just keep going, all right? So that means that 12, 14, 16, 18, 20. So basically each of these larger marks is going to be 10, right? So set that up that way. And then remember, you're going to have to create that parabola based on these parameters here. It's going to be 20 high, and then you have to find the vertex and then set your equation up and plug in your vertex, the numbers that you found from here. And remember, that's like this point up here once you put it on the graph. And then solve for A. Remember, you solve for A by taking one of those points that you already know that's on the graph, okay? So just look at the earlier problems in the video and you should be able to figure that out. Okay, so the rest of this packet is all review. So this is domain and range or graphing characteristics. So I go back to week 1 to review this and check out the videos there to help you out, or Edpuzzles. And then this is solving quadratics. So this is from the previous, this is also from week 2. So go back and look at that to look up solving quadratic equations to be able to figure that one out. All right, that's it.